I promised in a certain way to show a circuit with which you can say find, indicate ultraviolet radiation, and especially in the ultraviolet C band. Say that is in general the harmful radiation from the sun, etc., etc. That ultraviolet C band is quite broad, and so I had to in a certain way limit my experiments. But I think this is a useful circuit. At first the schematic, it's here. Perhaps I have to make a second video, but anyway. Here is the ultraviolet radiation. It was also in an earlier video. I want to give the link in the description. And this LED here, this one, strays out ultraviolet C radiation. And I've also made a switch here with which I can also generate ultraviolet A radiation. So you can see what happens here. Ultraviolet A and ultraviolet C, but now only ultraviolet C, and well, it is a radiation with much more, say, energy. And that's a kind of explanation why that ultraviolet C LED gets so hot. Anyway, this is the detector. And I found on the World Wide Web, especially on AliExpress, a different units that could say indicate, measure, not measure, of course also measure, but that could be used as an indicator for ultraviolet C. And I found these two units, but I found in practice that these units did not give out, say, a good voltage. They are usable, no problems with that. And here you see a LED that will shine on when you add voltage to these units. These are sensors, by the way, that's what I wanted to tell. Two sensors here. But anyway, these ones were not so sensitive, but this one here was very sensitive. Here, this one. And I want to give the description in the text box. It's blue. You can find it surely on Ali, etc., etc. And here is that ultraviolet sensor that is very sensitive, gives out a good voltage, etc., etc. To, say, supply the radiating LED, I needed, of course, a power supply. And like we know, everything is as good as its power supply. That's an old saying. So this ultraviolet LED, this type, by the way, here, and I've also showed that in an earlier video, this ultraviolet LED is driven with this stabilized voltage supply at approximately 6 volts. Pen over somewhat. And here is the detector. Like I told, it's the blue one here. It detects ultraviolet radiation. And could be an issue, of course, that the frequency band where this detector works is quite small. But of course the sun shines out a big bunch of ultraviolet radiation, and when you want to know more, go to the World Wide Web study how much ultraviolet radiation is sent out by the sun, etc., etc. The good thing of this blue unit was that I only had to add a small voltage source here, 2 batteries of 1.5 volts, a micro ammeter of 100 microampere. It sends out, this unit sends out, when it receives ultraviolet radiation, it sends out a current. So there was a very simple and easy way to make that current visible with a micro ammeter, and that's 100 microampere. To protect it, always use here 2 silicon diodes. One of them is reversed so that the voltage cannot go too high, damaging that meter inside such an microampere meter. There is a high resistance coil that's extremely sensitive and can burn out very easily. The whole thing, and I mean the detector, is supplied with a few batteries. Here you see these batteries. I have taken AA types, but perhaps AA types are also good. It gives out 4.5 volts, but there's an important thing to tell that the voltage must be stabilized, and to stabilize that in a very easy way, I've used here 7 silicon diodes. So here's the power supply, 4.5 volts. It sends its voltage and current into the positive here, and from the positive here to the negative I have mounted 7 silicon diodes. Each silicon diode gives a voltage drop of approximately 0.7 volts. That means that it acts as a zener. You can see that here. Quite a bunch, but of course I want to make that better, solder them all properly in, etc., etc. Well, that was more or less all to tell. The schematic again, pen over somewhat, and then I will show the effects of ultraviolet radiation, ultraviolet C radiation in this frequency band here. How the detection circuit can say detect that. I have put down my camera. So anyway, this is a microampere meter that indicates the level of radiation that is straight out by this unit, and it was earlier on my YouTube, not earlier, but anyway, it was now on my YouTube channel, and here you can see that this LED radiates ultraviolet C. So let's see how the microampere meter reacts when it receives, and especially that blue unit reacts when it receives this radiation. So you can surely see that a meter, I want to focus it better when it's possible and when my camera doesn't drop, always a problem, but anyway, here you can see how sensitive this blue radiation detector is in say presenting the the current. So again, here is the ultra stop. It drops. That's very bad. That was not the meaning anyway. I don't want to make a new video, but anyway, here is that ultraviolet radiation again, and let's see how it affects the meter. So you can surely see on the, not on the background, but on the front, that the meter is extremely sensitive to that radiation. So again, UVC straight out and detected by the unit that is, by the way, very cheap to buy or via AliExpress, etc. Anyway, do it again. And of course, and what I'm doing, I want to show it, what I'm doing. Here is what I'm doing when that meter moves. That's also, say, kind of proof that this circuit works. Here's what I'm doing. This is the radiator and this is the sensor. I move the radiator to the sensor. And of course, we know, you know, that, say, calibration is key. One of the most, in this very, very simple circuit, most important things is that the voltage must be stabilized. You can see the meter move again. That the voltage must be stabilized, and that was done with these 7 silicon diodes in a row. You can use, in fact, any silicon, any normal silicon diode, say the 1N types, 1N4007, 1N4002, each zener drops the voltage, stabilizes the voltage around 0.7 volts. There's a small deviation there when we are talking about how to make such a zener, etc., etc. But I made it because otherwise there could not be a proper calibration. So I drop down the voltage of 4.5 volts a little bit down to, say, 3.5 volts or 3.8 volts for the good reasons that without that you cannot have reliable measurements of UVC radiation from the sun, etc., etc., or other sources. And in fact, the whole circuit is very primitive, but it will surely work. Especially this part, this is the detector, Ultraviolet C detector. And say, when you have another unit here, they are also on AliExpress. You can also detect other ultraviolet frequency bands, say UVA, etc. Thanks for watching.